Hey guys, this is Carrie, and this is lesson 12 from trig waves, or from trigonometry, and we're going to be talking more about trig waves today. So in case you guys were wondering, a lot of the time, like if we were in class, I might have condensed some of these lessons together to make a little bit longer of a lesson. But I think now with remote learning and no pressure of the regions, we have a little bit more time to go through these at a slower rate. So the unit might become long lesson-wise. We've already had that midway through the unit assessment. But trig waves are sort of the last big topic in this unit. So we'll spend a couple more days on trig waves, and then I'll put another Delta Math quiz up online. All right, so the most important thing with trig waves is you need to have a picture of sine of x and cosine of x. So it says to use degrees here, but I think at this point we're all really comfortable with radians. So let's use radians. So sine we know starts at 0, 0. And if we're going to graph one cycle of it, the word that we use for that is a period. So we'll graph one period. It goes up, it comes down, and it goes home. And the reason why we say this is one cycle, right, is after this, it just completes the same pattern again. Up, down, back home. And so there's no real reason to keep drawing this forever. That first pink cycle right here captures all of the behavior for the rest of the graph. So that being said, we need to label some important key values. So we know it starts at 0. For regular y equals sine of x, we know that the amplitude is 1 because it goes up 1 and down 1. And we also know that the period is going to be the amount of time before sine starts to repeat. Now all of this comes from angles in the coordinate plane. So if you think about an angle in the coordinate plane, it starts at 0 degrees, and then it changes. But when it completes a full circle, it starts to repeat that exact same pattern. And so a full circle is 360 degrees. But because we're thinking in radians, a full circle would be 2 pi radians. And that's a fact that we know about radians. So we know a full cycle here is connected to this idea of completing a full rotation. So this will be 2 pi radians. Halfway in between that, it hits the point 0. All of the important values here, like the maximum, the 0, the minimum, those are the key values on the x-axis as well. So here where it hits the middle, that's halfway in between 0 and 2 pi. That's going to be 1 pi, or just pi. Halfway in between 0 and pi is pi over 2, because it's halfway in between 0 and pi. And then if we count them 1, 2, 3, this will be 3 pi over 2. All right, so we've got our graph of sine. Now it's really important that we continue to draw these each lesson because they are our reference point for the entire part of trig waves. So for regular cosine, y equals cosine x, this graph will start at 1. So they are very different from sine actually. Sine starts at 0, cosine starts at its maximum value. And then it descends through 0, hitting its minimum, back to 0, and then hitting its maximum. So this is down 1. All right, so regular cosine has an amplitude of 1 as well because it goes up 1 and down 1. All right, so hitting the key values on our grid here, a lot of students in previous years, I'm just going to show you with a highlighter here, a lot of students in previous years have made the mistake of only graphing cosine up till here. That's not a full cycle. You've got to include this top part as well, because a full cycle for cosine should bring it back to where you started, which is at its maximum value. So make sure you have that. All right, so now being specific about these key values. Where it hits its maximum again, that's a full cycle, 2 pi, 360 degrees. Halfway in between, where it hits its minimum, is pi. Halfway in between those, where it hits 0, is pi over 2. And halfway in between pi and 2 pi, that's 1, 2, 3, 3 pi over 2. All right, so we've got our sine and cosine graphs, and that's super nice. Let's determine the equation of the wave shown below. So the first thing that we need to do with this wave is figure out, is it a sine wave or cosine? And so using our reference graphs up above, it does look quite a bit like the cosine graph. So definitely it's going to be y equals cosine of x. Now it is a little bit similar. The period is 2 pi here, as it was before, but the amplitude is 5. And so to account for the fact that we're going up 5 and down 5, we need to have a multiplier out front of 5. So the amplitude will go here. Now because the directionality matches here, like they both, there's no reflection over the x-axis, it's going to be a positive 5. So this is our final answer. On the grid below, draw one period of the graph of the function y equals -3 sine of x. Make sure to label all values on the x and y axis. All right, so when you have a problem like this, the way I think about it is we know normal sine x looks like this. -3 sine x is going to do two things. It's going to flip it upside down because it's negative. So it's going to be the reverse of that, where it goes down first instead of up first. But then also, because of the 3, it's going to be 3 times as high because the amplitude is 3 times as large. So the oscillations are going to be 3 times the height. All right, so here we have 1, 2, 3, down 1, 2, 3, and we're going to have a negative sine graph, so it's going to go from 0, 0, the same way normal sine goes from 0, 0. It's going to go from 0, 0, down 3, up to 3, back to x equals 0. Not x equals 0, y equals 0. So on our grid, this will be 0, 2 pi, pi, pi over 2, and 3 pi over 2 at the maximum and minimum values. We know that we've got the amplitude correct as well because we showed that on the y-axis. All right, so that was the key material from yesterday's lesson. Let's see how things changed today. All right, so the first thing that we're going to talk about is a problem like this one. On the grid below, draw one period of the graph of the function y equals 2 sine x plus 4. So you might think to yourself, well, what is different about this problem? Why isn't it part of the do now? Well, it's this plus 4 right here. So we're wondering, how does this plus 4 affect the graph? So if you think about this graph without the plus 4, well, it's just going to be like a normal sine graph. It's not going to be flipped because it's positive. The 2 is going to make it twice as tall and twice as shallow on the descent there. But we've talked a lot about adding numbers outside of the parentheses. This is or outside the function. This is an outside transformation. So an outside transformation is always a shift in the y direction. So it's going to be up or down 4 units, the whole graph. And in this case, outside transformations, those are the easier ones. Those go in the direction you expect. So it's going to be up 4 units. And the easiest way to do this is, because of the symmetry of the sine graph, you have this middle line, and it has a vocabulary word. This middle line, usually the x-axis, is called the midline. Because we want to shift the entire graph 4 units higher, we know that our midline is going to be shifted up 4 units. So instead of being at 0, 0, or not 0, 0, instead of being at y equals 0, our midline is going to be shifted up 1, 2, 3, 4 units to the line y equals 4. And this midline, now, this is where the graph starts to oscillate about. So sine usually starts at 0, 0 on the midline. Because we've been shifted up 4, our new sine graph will start at 0, 4. It's just shifted up 4, because that's what outside transformations do. And it's going to go from 4, it's going to go with the amplitude here, up 2 units to 6, back down to the midline, now down 2 units to 2, because 4 minus 2 is 2, and then it's going to go back to the midline. And the same way that our sine graph before completes a full cycle when it returns to the midline, our graph here completes a full cycle at the midline. So here, this is 2 pi. Here, this is 0. Right here where it hits the midline, that's pi. Where it hits the maximum, that's pi over 2. And where it hits the minimum, that is 3 pi over 2. The only difference here is the midline is the line y equals 4, because the plus 4 outside transformation shifts everything up 4. All right, so for this one, you guys have a checkpoint problem here, but I'm thinking that it might be a little bit tricky just because it's cosine instead. So give this one a shot on your own and see if you're able to solve it. Now we are going to review it. So we've got our y-axis, we've got our x-axis. This time our outside transformation is -3. So that's going to move the whole graph down 3. So if we think off to the side, well, cosine usually starts at 1, goes down, and then up. In our case, though, because it's a 5 here, it's going to go from 5 all the way down to -5. Sorry, I'm trying to color code this, but it's hard to just keep track of all the colors are changing. This -3 here, though, it's going to take our midline, and it's going to move that midline down, not all the way down to 5, sorry, down 1, 2, 3 units. It's going to move it to here at -3. All right, so let's see how this looks in our picture. I feel like we've got a basic idea for how things are coming together. So we're going to move the midline down 1, 2, 3. So now the midline is y equals -3. Cosine always starts at the maximum value. But instead of starting at 5 here, because the amplitude is 5, the height of the vibration is up 5 and down 5 for our wave. I think about sound vibrations, that's why I use the word vibration for the wave, or oscillation is another word that we've been using. So the oscillation is going to go up 1, 2, 3, 4, 5 units, which will put us at 2 to start. So it starts at its maximum. So it starts 5 units higher than the midline. It comes down to -3. It goes through and hits its minimum value. For the minimum value, the oscillation is an amplitude of 5 here, so it's going to go down 5. So that's going to be -4, -5, -6, -7, -8. Or just -3 minus 5 is -8. So the minimum is -8. It returns back to the midline, the same way that it did here. And then it goes all the way back up to all the way back up to the maximum here. And so filling in the values, where it returns to the maximum, that's a full cycle, 2 pi. In the middle here, that's pi. Where it hits the midline, that's going to be pi over 2. And here where it hits the midline, that's going to be 3 pi over 2. So these outside transformations are a little tricky to work with. Hopefully that helps. You have one more to practice with here. This one is going to be a little bit cool though, because you're graphing it on the domain from -2 pi to 2 pi. So you'll have the normal side, but then you'll also have the repetition, the other side as well. So you'll get 2 periods for this one, and it should look something like that, but perhaps shifted with a different amplitude. All right, so we've looked at changing a lot of the numbers inside of these problems. The one number that we haven't changed is a number inside the parentheses. And connecting this back to what we were talking about with sounds, this is the amplitude, the number out. Sorry, I should really color code these better. So this is the amplitude, the number outside, and this is the height of the oscillations. So if you want to scream, it would make the wave tall. And if you want to whisper, it would make the wave really tiny. And that number right here, that's the amplitude. However, that's not the only way you could change a sound. You can also change a sound by making the sound have a lower frequency or a higher frequency. And what that means sonically is, this is my normal frequency. A low frequency would be, this is a really low frequency. The pitch of it is actually lower. And if you talked in a really high-pitched voice, like a Mickey Mouse voice, that would be a high-pitch voice. So, this is a really high frequency. And that's connected to this idea right here. So by putting a number there, we're going to change the pitch of the sound. And what the pitch corresponds to mathematically is it corresponds to the sound, the period changing. Now, unfortunately, this one is not as easy to work with as the amplitude. So let's look at an example of how to do this, being problem number 1. All right, so sine of x we definitely feel comfortable with. Now, we know the amplitude is 5. We also notice that there's no vertical shift here, so we don't have to worry about shifting the midline. However, sine is going to start at 0, 0. It's going to go up to 1, 2, 3, 4, 5. It's going to go down to 0, 0. It's going to go down to its minimum of -5. And it's going to go back home to 0. Now, it looks very similar to the sine graph that we created before. This blue piece here, though, does change the numbers that go in these spaces, because the period is going to change. So this is no longer 2 pi. Sorry, that arrow is a bit off. So in order to be exact about what number is going to go there, the way that we figure that out is we say, okay, well, sine of x repeats when the inside actually let me just use the one from the problem. Sine of 1/4 x repeats when the inside which is that thing right there, hits 2 pi. Because when that inside function, 1/4 x, when that hits 2 pi is 360 degrees a full circle. So basically the equation that we want to solve is we want to know, when is the inside, this piece right here, when does that inside equal 2 pi? And that's a question mark there, because that's the question we're trying to solve. So the inside is 1/4 x, and we want to know for what value of x does that hit 2 pi? Because that would be one full cycle, and that would be the value that goes right here. So to solve this equation, it's actually pretty easy, even though it's a fraction. Division by 4 is canceled out by multiplication by 4. So we do that on both sides. And we're left with 1x, which is just x equals 8 pi. So by making the inside 1/4 x equal to 2 pi, we find that in order to complete a full cycle, x has to equal 8 pi. So we put the 8 pi here. Halfway through that, from 0 to 8 pi would be 4 pi. Halfway between 0 and 4 pi would be 2 pi. And then halfway between 4 pi and 8 pi would be 6 pi. Now it's really important that you see why this happened. So we're going to do a couple of more examples, and I think that the clarity will increase each time we work on them. So let's do another one here. Graph one period of this wave right here. Okay, so we know there's no vertical shift because there's no number here, so we can straight up draw it on our x-axis, with the midline on the x-axis, sorry. All right, so the amplitude is going to be 3. 1, 2, 3. It's going to go up 3, down 3. And for cosine of x, it's going to start at its maximum value of 3. It's going to go down. Whoa. Cosine always starts at the maximum value, so it's going to go down to 0, down to the minimum, back to 0, back to the maximum. Now, usually when we fill these out, in the past, this had always been 2 pi. But because the inside is not just x, because of the pi over 6, this is no longer 2 pi. So the way that we calculate the inside is we want to make this pi over 6x equal to 2 pi. So let me write that down. The cosine graph will repeat on the condition, or when this inside function here is equal to 2 pi. Because when the inside is 2 pi, that will be a full circle. So to make the inside 2 pi, we set the inside pi over 6x equal to 2 pi. We multiply by 6 on both sides. That leaves us with pi x equals 12 pi. We divide by pi on both sides. And we find that the value that completes a full cycle is x equals 12. So on the x-axis, we put 12 here at a full cycle. Not 12 pi. This time the pi's canceled out because of the division by pi. Halfway in between would be 6. Halfway in between here is 3. Halfway in between 6 and 12, you could average those. Is 9. Another way to think about it is 3 plus 3 is 6, plus 3 is 9, plus 3 is 12. So these increments are symmetrical, they are identical. All right, we've got a nice graph of cosine. All right, so let's do one more of these. Graph one period of the wave whose equation is this. Y equals 8 cosine pi x. All right, so we have no vertical shift, so that makes life nice. We've got a cosine function so that starts at its maximum value of 8. Now, you don't have to draw all the tick marks, right? Because if you just put an 8 there and a negative 8 there, it's quite clear what values those are. So we're going to start at 8, because cosine starts at the maximum. It's going to descend to 0. It's going to descend to the minimum. It's going to ascend back up to 0. And then to complete a full cycle, it ascends back up to the maximum. Now we can't fill in these tick mark values yet, because the pi here is going to change the value of this one. Of the full cycle. So the way that it changes it, right, is we want to know, to complete a full cycle, the inside has to equal 2 pi, because that's a full cycle. The inside here is pi x. So we want that to equal 2 pi, because then it will make a full cycle. Solving for x here, we divide by pi on both sides. And we find that we'll complete a full cycle when x equals 2. So we put 2 here for the full cycle. Halfway in between those is 1. Halfway in between 0 and 1 is 1/2. And then halfway in between 1 and 2, you could do an average there. 1 plus 2 over 2 is 3 over 2, which you could write as a decimal, but there's no real nice way to write that. So 3 over 2. And we've got our graph graphed. Alright guys, so it's time for you to get some practice with this. So please do problems 1, 2, and 3 before continuing with the rest of the lesson. Number 3 has an interesting thing where you have to combine in all of the things we've learned: the amplitude, the period change, and the vertical shift. So see if you can do that one when you get to it. Alright, I actually think this is probably a good place to end today's lesson. So we'll talk more about the remaining pieces next time we meet. Good work today, guys. Hope to see you soon or hear from you.